Well, welcome to another video in our algebra series on finding rules from patterns. This one is a very tricky one to think about and to explain because sometimes it's just so natural to us that we find patterns that it's hard to actually explain what we're doing and to talk about why we make these choices, because half the time we don't know why we're making these choices. And we're actually quite good, human beings are quite good at identifying patterns. So if you're working out a food allergy, you have to find a pattern between what you are eating and the symptoms that you get. If you're playing basketball, you need to work out the patterns of the game, when your team needs to move and how they need to move, and what your other and also what the other team is doing, and what patterns can you work out from what they're doing, so you can take advantage of knowing that and find the weaknesses in those patterns. Driving on public transport, another example. There's lots of patterns in when the buses are coming, or what the cars are doing when they're driving. And cooking. And we'll talk about cooking a little bit later. Alright, so I want to basically, at the end of this video, help you to understand why you're making choices when you're solving questions like this. So this one says, write an expression for how many matchsticks are in version V of the pattern. So if you're writing an expression, then you should have a variable in that expression, and they've given you a variable here, which is V. Okay, so let's say this is version 1, 2, and 3. And the version actually matches up with how many shapes there are. In this one, there's 1 shape, 2 shapes, and 3 shapes. So for this kind of thing, you might be able to see straight away that your expression is going to be 1, 2, 3, 4, 5, 6, 7 V. And that would be right. Okay, but if you can't see that straight away, here's one way of thinking about it. Let's say I have matchsticks, which is M, and I have V, which is here. You can make a table. So if V is 1, you've got 7 matchsticks. 1, 2, 3, 4, 5, 6, 7. And you're adding another 7 over here. So that's 14 matchsticks when V is 2. When V is 3, you've got 21 matchsticks. And from here, you might be able to see what you should be thinking, what's the connection between these numbers? And you should be able to see that really this number is always 7 times this number. M is always 7 times V. So your expression is 7V, and if they asked you to write an equation, you would write M equals 7V. Okay, so some tips: draw a table and look for a pattern between the two variables in your table. Okay, so let's get up to the next one, and I think you'll soon see that this is a little bit harder than the previous one. But let's try it. Let's try and draw our table anyway. So let's say C is the number of chairs, not C is chairs, C is the number of chairs. And T is the number of tables. Well, you've got, in the first one, there's 5 chairs and 1 table. Then we've got 8 chairs and 2 tables. Then we've got 11 chairs and 3 tables. And you might say, okay, well, we've got to write an equation, relating number of chairs and tables. So if I just look at the first one, there's 5 times as many chairs as tables. So you could write number of chairs equals 5 times the number of tables. And that works for the first one, doesn't it? But then the second one doesn't work, because 2 times 5 is 10, not 8. So you might say, okay, let's change this. That's fine. I'll just change this to 4. But then you look at the first one again and you realize that doesn't work either. That doesn't work for the first one now, because 1 times 4 is 4, not 5. So you think, okay, this is hard to do. I don't really understand what's happening here. Now what I want you to do, let's take a break from this for a little bit and let's go to cooking. Because I think this cooking example will help us a little bit. So just imagine you're cooking scrambled eggs and you decide to put smoked paprika in. That's smoked paprika over here. Just a spice. And also decide to put vegetable stock in. It's like another spice. The scrambled eggs are much better than usual, but you're not sure whether it was the smoked paprika or the vegetable stock. And the question is, what should you do next? How can you do it? How can you work out whether it's the smoked paprika or the vegetable stock or both? Now, one way of doing it, I think, is to make scrambled eggs again and only put one of the ingredients in. So only put smoked paprika in. And then the next day, make it only with vegetable stock. And think about, well, what are the differences between the two? And which one is contributing to this delicious flavor? And maybe it's both of them. Maybe you realize at the end that it's both of them, but that will help you to work out which ingredient is the important ingredient. So when we get to this question, I'll go back to the previous slide where we've got the table. What we can do is we can work out, we'll use that piece of information. The first thing I want you to do is to think about, are there any patterns here? Is there anything that's happening consistently each time? Well, these are going up by 1, and these are going up by 3. Now, the reason I used the cooking example before is because there's often more than one thing going on at the same time in these patterns. In this one, there was only one thing going on, which is you multiply V by 7 to get to M. But in this one, there could be more than one thing going on. Now, when you're increasing by 3 each time, that's like a 3 times table. If you have the 3 times table, you start with 3, then you go to 6, 9, 12, and each time you're going up by 3. So what I want you to do, this is kind of like the cooking example where we cooked only with one ingredient. Why don't we write the 3 times table in another color over here, and we'll have a look at that and we'll see what's happening. So in the 3 times table, we start with 3, and then we get 6, and then we get 9. So maybe that's one ingredient. Maybe the 3 times table is one ingredient of this. Now, if it was only like the 3 times table, it would be like if you had one table, there was 3 chairs, and if you had 2 tables, there was 6 chairs. And that would be, the equation for that would be C equals 3 times T, wouldn't it? If this was C over here. But there might be something else going on. So then we can look at the difference between this 3 and the 5, and the 6 and the 8, and the 9 and the 11. And I wonder if you can see any patterns there. Because there is actually a pattern. The real number of chairs is always 2 higher than the number of chairs I would get from this equation. So that means you can actually add 2 to this equation, and then it makes sense. So the final answer is actually 3t plus 2. Let's test that. So let's test it. If t is 1, then the number of chairs is 3 times 1 plus 2. So if T equals 1, C equals 3 times 1 plus 2, which is 5. So that works. So what about if T equals 2, C needs to be equal to 3 times 2 plus 2, which is 6 plus 2, which is 8. So that works as well. And if T equals 3, then C is equal to 3 times 3 plus 2, which is 9 plus 2, which is 11. So this works for all of them, this formula. And I just want to go back to how we did this. So we noticed a pattern. It goes up by 3 each time. And if it went up by 3 each time, it would be like C equals 3t. But also, we have to add 2 in each case. So then we realized that you had to do 3t plus 2. So there's the two ingredients here are multiplying the number of tables by 3 and adding 2. All right. And you can see how this works in the real picture as well. If I didn't have these 2 chairs on the end at all, then that would just be 3t. Number of chairs is 3 times the number of tables. That would be simple. But I've got these 2 chairs on the end, and that's what's causing the problem. So you have to actually add 2 chairs. Okay. Scrambled eggs. All right, this is the last question we're going to do. All right, so write an expression for how many white tiles are needed for each version of the pattern. So if that's our 4 versions, how many white tiles do I need? So let's say I've got V version. So version 1, 2, 3, and 4. And I've got W for white tiles. So in the first one, there's 1, 2, 3, 4, 5, 6, 7, 8. In the second one, there is 10. In the third one, there is 12. And I'm going to guess the fourth one is 14. Now, I'm sure you could have guessed that fourth one was 14 as well, which means, and if you did guess that, you've probably noticed that it goes up by 2 each time. Okay, so that's kind of like the 2 times tables, isn't it? It's kind of like W is, well, the number of white tiles increases by 2 each time. So what if it's just 2 times the number of the version number? But it's not, is it? Of course it's not. 2 times V is, if V is 1, that's 2. So that doesn't work. 2 times V would be like this. 2, 4, 6, 8. So it goes up by 2 each time, but it's not. The real number of white tiles is 8 in this one, and it's 10 in this one. It's 12 in this one, and it's 14 in this one. So if we've worked out one part of the pattern, which is 2V, we still need to work out the other part of the pattern, and we get that by thinking about how do I get from here to here? For all of these, you have to add on 6 tiles, don't you? So 2V plus 6. And let's think about this visually as well. It's probably good to think about it visually. Each time, can you see, it's like I'm adding in this middle section here. That's new. It's like, okay, I'm adding in this section here. I'm adding in this section here. And each time you're adding in 2 tiles. But if it was just W equals 2V, then that would ignore this tile, that would ignore this tile, this tile, this tile, this tile, this tile, and this tile. So I've got 6 extra tiles that I have to include. And those 6 tiles, the outside ones, are on every single version. So you're always adding 6. Alright, well I've done my best with this one. I think it's very tricky to understand and explain. Feel free, if you like the visual way of doing things, feel free to do it with the visual way of doing things. If you like the tables, then draw the tables. They're going to be useful for later on. But I want us thinking about what's changing each time, each new section of the pattern. And that's like a times table that you're using. And then what do you have to add or subtract to make it, to take into account all the number of tiles? All right. Well, I'll see you next time.